Now your next module is three-phase AC circuit. As its name suggests, three-phase means we are having wires. Okay. One wire is of red color that is denoted by R, another wire is of yellow color that is denoted by Y, another wire is of blue color that is denoted by B. So three phase means three wires and three wires of different color. All wire having different current in this. Actually that different current depends on the load also. Okay. Now suppose I gave you in your hand that three wires and I told you to connect all these three wires. Then how will you connect? Either you can connect it like this, all connect with a single tie like red wire, yellow wire and blue wire, right? This is one of the type of connection. Or you can connect red wire connected with a yellow wire, then yellow and red wire. This is another type of connection. So it looks like a star, that's why it is named as star connection. It looks like a delta, that's why it is named as delta connection. Okay. If I make it opposite, then star looks like a Y. So other name of star connection is Y connection, that is represented by WYV. And if I make it opposite like this, then it will form a mesh connection. So they can give you by another name also. Star connection, another name is Y connection. Delta connection, another name is mesh connection. Okay. So now in this we'll deep learn about the star connection as well as the delta connection. In the star connection we are having current would be equal. Line current and phase current would be equal, but there is a difference in the voltage, in the line voltage and phase voltage, that is VL VPL. Similarly delta is opposite, but in delta voltage is same, means the line voltage and phase voltage is same. Current is opposite. Current is opposite means IL is equal to root 3 IPH. Okay. Now the thing is you don't know what is line current, what is phase current, right? So for that we studied about the star connection. As you know that star connection looks like this, right? Star connection looks like this. Of red color R, this is of yellow color Y, this is of blue color B. Okay. And where these all the wires are connected, that point is known as neutral. So this is the neutral wire. Got it? So it is a star connection. It looks like a star connection. Now the question is what is line exactly and what is phase exactly, right? If there is a plain wire, then that can be considered as a line. Okay. So like suppose in this wire, how much current is flowing? IR. In this, how much current is flowing? IY. And in this, how much current is flowing? IB. Okay. So can we say that all the wires which are flowing in the plain wire are the line current? Plain wire or line wire, one and the same thing. Got it? Now next, wherever these are the windings, these are the windings. Wherever the windings are there, that is technically known as phase. In our language, we called it as a winding, but in their language, technically it is known as phase. So the current flowing in the winding, that would be the phase current, correct? So here the current is moved from N to R, so we can denote it by INR. Here the current is moving from N to Y, so we can denote it by INY. Here the current is denoted by IN, right? So IR, IY, IB, all these are the currents flowing in the plane wire. Can we say that IR, IY, IB is the line current? Yes or no? So line current is always denoted by IL. Okay? Line current is always denoted by IL. Now the next is the phase current. Phase current is the current which is flowing across the winding, that is INR is equal to INY is equal to INB is equal to IPH. Right or not? Right? So tell me, according to you, IR and INR is the same current or the different current? IR and INR, it would be the same current because there is no current diversion, right? So from this, can we conclude that line current would be equal to the phase current always? Yes or no? Okay, understood? Okay. Now we'll discuss about the voltage in the star connection only. One is this one is R, this one is Y, this one is B. Okay, this one is the neutral N. So now we'll mark the line voltage. Line voltage is always between the line, that is between R and Y. We can mark it as VRY, right? Between Y and B. We can mark it as VYB. Between R and B, we can mark it as VRB. Yes? So can we say that VL is equal to VRY is equal to VYB equal to VRB, because all these are the voltage as a line voltage. Now next we'll mark the voltage across the phase. The voltage across the phase connected with neutral and R is VNR. For this one, VNY, and for this one, VN, right? So all these are the phase voltage. Phase voltage is VNR is equal to VNY is equal to VNB. So now can you tell me, is VNR would be equal to VRY? Yes or no? No. VNR can be equal to VRY. As you can see that VRY is made up of two component now. One is the VNR and another one is the VNY, right? So it means in this case line voltage and phase voltages are not equal. They are unequal. Means there is some relationship between this, right? So remember you have in the 12th class you have studied the relation that F is equal to, if we are having force is having two component, one component is F1, another component is F2, right? So how can we define the force that F1 square plus F2 square plus 2 into F1 F2 cos of 60 degree? Sorry, 60 degree, I'll tell you how it comes. So similarly, can we say that VRY is made up of two component? One of the component is VNR and another of the component is VNY. Yes or no? Because if it is N, then it is phase. Can we say that VRY is made up of two component? R means VNR, Y means VNY. Okay. If N terms come, then it is a phase voltage. If no N terms come, then it's a line voltage, right? So according to this, VRY formula would be root of VNR square plus VNY square plus 2 VNR VNY cos of 60 degree. 60 degree will come through the phasor diagram that I'll tell you later on. Okay. So VNR is the line voltage or the phase voltage? As I told you, whenever N is come, there is a phase volt. Can we say that VPH square, VNY is also the phase voltage, VPH square plus 2 VPH square cos 60 is 1 by 2. All I am talking about the balanced load. Okay, balanced load means there is equal impedance. Like if this is 2 ohm, this is also 2 ohm, this is also 2 ohm. That's why I'm considering the voltages, all the phase voltages are equal. Okay. So VRY is the line voltage. We can denote it by VL. If I'll solve it, then value would be how much? VPH square, 2 and 2 cancel. So it would be 3 VPH square, right? So square and root would cancel. The final answer would be root 3 VPH. Got it? So what we have studied that in the star connection line current is equal to the phase current but line voltage and phase voltages are different, right? That's what I told you. This is for the star connection. But there is one more thing we have to consider, angle difference also. So VL is equal to root 3 VPH is angle is 30 degree. How this angle 30 degree come? Whenever there is a line voltage and phase voltage, angle difference between line voltage and phase voltage is always 30 degree. Okay. Now the question is how this mm, how this 60 degree come? That comes through the phasor diagram. Okay. So draw all the line voltages. How many are the line voltages? Three. One of the line voltage is how much? VRY, right? Another line voltage is VYB. Another line voltage is VRB. Correct? So VRY, VYB, and VBR. So some of the students ask me that, ma'am, this sequence is same. So sequence is like RYB, RY, YB, and then VR. Got it? Okay, so it would be VRY, VYB, and VBR. Now draw the two components of VRY. Okay, one of the component is VNY and one of the component is VNR. Yes or no? Okay, one of the because it's VRY na, just put N over there, NR and NY. Just extend it over here. One of the component is always positive and one of the component is always negative. You can take any one. Okay. If we'll extend V and Y, then that would be minus V and Y. Yes? Okay. Now tell me the two component of VYB. VNY, VNB, right? So V and Y we already did. V and B would be like this. Okay. Again, one component negative, another positive. Now extend it. That would be minus V and B. Extend this VNR. That would be plus VN. Right? So this is your phasor diagram. All the line voltage having two components and just place it n over. Got it? Now see, according to this, we want the angle difference between NR and NY, right? Now tell me, NY is the phase voltage, right? RY is the line voltage, right? So angle difference between the line voltage and phase voltage is how much? Angle difference between 30 degree. I just told you na, angle difference between line voltage and phase voltage is how much? 30 degrees. So this would be 30 degree. Again, this is line voltage and phase voltage. This would be 30 degree. 30 and 30, that would be 60 degree. We want angle between NY and NR, right? So NY and NR is 60. Got it? So this is your complete derivation of star connection.